Hi there. Today I'm going to be talking about the impaired water body, water quality monitoring, and remediation measures for Lake Kilby. My name is Zachary Hirsch. Some location and information about Lake Kilby. It is located in Suffolk, Virginia, northwest of the Suffolk Municipal Airport and south of Pitchkettle Creek. Lake Kilby is located within the Hampton Roads watershed, and state water body type is identified as a reservoir. Lake Kilby is over 200 acres in size. Lake Kilby is listed as impaired because it does not meet one or more of the water quality standards set by the state of Virginia or the government level as the EPA. Lake Kilby in its entirety has been placed on the 2018 EPA 303D list for dissolved oxygen impairment. Lake Kilby has been approved for a TMDL, but drafting process has not yet been completed. The 2002 EPA 303D listing had no cause listed of impairment, but was listed as threatened. The 2008 EPA 303D listing had listed the water body as impaired for total phosphorus and dissolved oxygen depletion. In 2008, the official Virginia state water body type was changed from freshwater lake to a reservoir. What's worth noting is Lake Kilby's surroundings. Lake Kilby is directly located in between an urbanized development of Suffolk, Virginia. Lake Cahoon, another impaired water body, is located upstream of Lake Kilby and also has a dissolved oxygen impairment. Spites Run Lake, which is located downstream of Lake Kilby, has a dissolved oxygen impairment as well as a chlorophyll A impairment. Lake Kilby is also surrounded by the Suffolk Golf Course, and Lake Kilby has a dense cypress tree swamp surrounding almost all four corners, north, south, east, and west. One of the major causes of insufficient dissolved oxygen quantities comes from excess organic matter in water, causing an overarching eutrophic condition. In order to fully determine the cause of Lake Kilby's impairment, the different water quality parameters should be monitored. Water samples should be taken and immediately measured for the following water quality parameters, including temperature, pH, turbidity, odor, salinity, and dissolved oxygen. Samples should be taken monthly within a similar time of day at a similar sampling location within Lake Kilby. In order to properly identify the cause of impairment, multiple samples should be assessed within the water body area as well as have a comparable reference site nearby that will help accurately identify the cause. This reference site should not be impaired, meaning it should be able to meet the TMDL requirements of Virginia and the government level EPA, as we need a baseline to compare the water body to. Next, I will run through a few of the EPA methods for determining these water quality parameters, starting with EPA method 170.1, which is temperature. The temperature measurement in a water body should be completed using either a thermistor thermometer or mercury-filled or dial-type liquid thermometer. When conducting a temperature measurement, the probe should be fully submerged for an accurate reading, and the measurement device should also be routinely checked against a precision thermometer certified by the NIST. In preparation for a pH measurement, EPA method 150.1 should be followed, where a pH meter is used to analyze the sample that had just been taken as soon as possible. The sample vial should be filled completely to ensure a proper probe reading, as well as be fully sealed prior to analysis as the sample could change with exposure to air. The probe should be calibrated with standard stock solutions of pH 4 and pH 7 and cleaned off with distilled water and a Kim wipe. What's great about the pH meter, it is not the glass pH electrode in general is not subject to solution interferences from color, turbidity, colloidal matter, oxidants, reductions, or salinity. Turbidity, the amount of light that is scattered by suspended matter, can be measured by the EPA method 180.1 using a turbidimeter. The EPA method applies to drinking, surface, and saline waters in the range of 0 to 40 nephelometric turbidity units. Once the sample is collected, the analysis should begin, although refrigeration or icing to 4 degrees Celsius could be an option to minimize microbiological decomposition of the solids. What's also worth noting is that the sample vial should be filled up to the top with the sample to receive a proper reading. Odor is also a parameter that could come in handy when discussing dissolved oxygen depletion. The main sources of odor include algal blooms, industrial waste, domestic sewage, disinfection byproducts, and dissolved minerals. The EPA method 140.1 is an odor measurement using the human nose. The human nose can detect odors up to 10 to the negative 19th molarity, which is moles per liter. The threshold odor test can be used where the tested water is diluted with odor-free water to 200 milliliters and is smelled in order from the odor-free water to the highest dilution to the lowest dilution, with dilutions continuing until no odor can be discerned. Water samples must be collected in glass bottles with Teflon-lined enclosures, and the odor test should be done immediately after collection. If not, the sample size should be 1,000 milliliters, filled to the top, refrigerated, ensuring no extraneous odors can be drawn into the sample. Salinity refers to the dissolved salt content within water. The EPA method 120.1 is a conductance measurement that uses a conductivity meter in order to measure the electric potential of a solution. The instrument must be standardized with a KCl solution before use, while when sampling the analysis should be taken as soon as possible to ensure the proper measurement. The units of conductivity is micro-mHOS per centimeters, which the units will be resulting in. Now finally, dissolved oxygen, the parameter in question, must be assessed as well to ensure the new remediation measures are having a proper effect on our water body in question. The EPA method 360.1 is a dissolved oxygen measurement using a membrane electrode. This probe is filled with a salt solution and has a selectively permeable membrane that allows for dissolved oxygen to pass from our lake water into the salt solution. The dissolved oxygen that diffused into the salt solution changes the electric potential of the salt solution, and the change is sent by electric cable to the meter, which measures dissolved oxygen in milligrams per liter. This can be used instead of the Winkler method if the measurement will be taken at the water body site. Now for some water quality control and remediation measures. First off, water quality is the chemical, physical, and biological characteristics of water, whereas water quality standards are the water quality goals of a water body or portion of a water body. Section 303D of the Clean Water Act authorizes the EPA to assist states, territories, and authorized tribes in listing impaired waters and developing total maximum daily loads, which are TMDLs. TMDLs establish the maximum amount of pollutant allowed in a water body and serves as the starting point for restoring water quality. Point source control permits and/or non-source control best management practices should be used. Best management practices describes ways to manage land and activities to mitigate pollution of surface or groundwater. Although the development of a TMDL is great for the future sustainability of the water body, the TMDL isn't the only way remediation happens. Normal citizens like you and me can have a clear effect on the water quality as well with our daily practices. Large majorities of runoff include garbage that have begun with our use. The prior knowledge of proper dumping practices could ultimately eliminate unwanted nutrient inputs, resulting in a lesser depletion of dissolved oxygen. Suffolk, Virginia is an urban area with over 90,000 residents and has an overall rain precipitation of 50 inches a year with 5 inches of snowfall. Runoff is inevitable. Stormwater drains that remove solid content could also help decrease nutrient levels in Lake Kilby. Also, higher walled bridges for the roads above the lake could also help decrease nutrient levels in Lake Kilby. As mentioned earlier, this lake has a dense cypress swamp around the area as well. This could possibly affect the amount of dissolved oxygen that is ultimately reaching the lake due to the idea of the diurnal oxygen cycle. The addition of dense amounts of cypress trees causes shade around the water body, which in turn limits the amount of photosynthesis that can occur from the equation solar energy plus 6CO2 plus 6H2O yields C6H12O6 plus 6H2O. This results in the depletion of the amount of oxygen that can be contained within the water body. The better management of these cypress trees could help promote a better amount of dissolved oxygen within the water. Another remediation measure includes an urban nutrient management plan, which could be used to manage the amount, placement, timing, and application of fertilizer, biosolids, or other materials containing plant nutrients in order to reduce nutrient loss to the environment. It is typically used in golf courses, athletic fields, community and business parks, common areas in developed communities, and residential lawns. Since these are common attributes of the Suffolk community, as it is an urban area, a nutrient management plan that could prove to be a solution to a nutrient pollution problem that causes algae overgrowth and dead zones in waterways. Thank you for listening, and I hope that Lake Kilby can soon be taken off the EPA 303 impaired waters list.